Hello, welcome to All Space Considered, everyone. I'm Dr. David Reitzel, and All Space Considered is brought to you by the City of Los Angeles Department of Recreation and Parks. We also like to thank Griffith Observatory Foundation, our exclusive nonprofit partner. We have a great show for you all tonight, and we have a great panel as well. With me tonight is Laura May Abron, my co-host of All Space Considered. And on the stage right now is also Daniel Perea, one of our producers and science communicators at Griffith Observatory, to start our show. And we'll introduce the other panelists as they come up here throughout the show. All Space Considered is usually on the third Thursday of the month. Today is actually Wednesday, June 17th, 2026, and we do this show live at Griffith Observatory within the Leonard Nimoy Event Horizon Theater. And people can come up, watch the show live. We stream it live, and that usually is on the third Thursday of each month at 7 p.m. But today, we are coming to you live from the 248th meeting of the American Astronomical Society. We're here in Pasadena, and we are thrilled to be here. In fact, we want to give a very special thank you to the AAS press office, who we are collaborating with to make this happen. Thank you for all the help we've gotten on this. Yeah. And if you like today's show, be sure to check it out on our YouTube channel, Griffith Observatory. You can click on the live button and you can see previous episodes and hear all about it. Tonight, we've got how to consider all of space. What do we do at All Space Considered? And then All Space Considered reporting on the AAS. Throughout the years, we've done some interesting things. We'll talk briefly about that. Tonight, we're going to talk about, as part of our space news, that it is actually Black Space Week. I want to make everybody aware of that. A send-off to MAVEN. The MAVEN spacecraft ended its mission. Primordial Phoebe, what is this all about? And then a Bolide over Boston. Has nothing to do with Boston baked beans, unfortunately, even if I'd like the alliteration. And then we have an out to launch section with Jared Head. He's our rocket scientist expert, and he's going to tell you about things that have happened in rocket launches in space. Then we'll bring up Ginger Rose Brucker, and she will talk about some amazing astronomical images, and we're actually going to compare some Hubble images, some Webb images, and others to some that amateur astronomers have taken, and see how great the amateurs have gotten these days. It's pretty cool. We have some space Pic competitions that you can join if you have some things to send in, and then we have our Mostest dark skies that we're going to talk about. Seems like every month there's always a new biggest, strongest, furthest, brightest, and that's our section, the Mostest, and this time it's the darkest. And then we have three guests from the AAS. We have Stephen Hummel to come talk about dark skies with us, Allyson, Bieryla to talk about CARE, one of the committees here, the Committee for Accessibility, Rights, and Equity. And then finally, we have AAS President Dara Norman, the 50th president, and we'll introduce each of them in more detail when we bring them up on the stage. But we've got an exciting show for you tonight. Well, we want to kick off tonight by talking a little bit about this background photo. It's a JWST image of the giant molecular cloud Orion A, located in Orion. We often pick a beautiful image to inspire people to kick off the show, and this is just part of that gorgeous star complex and those wonderful images that JWST has been bringing. Now, All Space Considered, it's Griffith Observatory's premier space news program, and it's been going on since 2008. And we've used this logo for a long time. I like to think it's our ode to light pollution, where we're celebrating those beams that come out of the Hollywood Bowl that's located near us. So we are doing bright sky astronomy at Griffith Observatory, but you can still see a lot. You see the moon, you see the planets, lots of stuff, and of course we host our show at Griffith Observatory. The show began in 2008. Laura Danley was curator, and she came up to me and said, let's have a space news show. And I said, okay, when? She said, how about this week? I went, well, okay. So we threw together some PowerPoints. Chris Butler, our current art director, joined us, and we just had a good time doing it. Eventually, the crew on the stage settled down to Laura Danley, myself, Tony Cook, who was our astronomical observer, and Patrick So, who was our theater programs manager. And we literally did cover all of space. We covered space flight, we covered planetary science, we covered cosmology. We do it all. In fact, we even decided, well, let's cover the Earth, let's cover life science, let's cover the interaction with the sun and the Earth. These are important things for people to know about, and we get all sorts at Griffith Observatory. The show is held once a month. Like I said, it's normally on the third Thursday. And it is in the Event Horizon Theater. And speaking of Event Horizons, this program you're seeing on the right-hand side had Leah Halloran, an artist, and Kip Thorne promoting their book, Warped Side of Our Universe. And that was a really special episode, and you can check that out on our YouTube page, of course. In 2025, we had a lot of guests. This is just 1 year. You can imagine what we do over all the years, but I like to point out in here a couple of people, our friends Jamaica Marshall, also Tim Russ. We had those for Black Space Week a year ago. We have Andrea Ghez was in there. She asked to have hers not streamed, so you cannot find that episode on YouTube, but she wanted a more personal, immediate experience, and she delivered. If you were there in person, you really got to connect with her and her science, and it was amazing. So sometimes you just have to come up to Griffith Observatory to experience it in person. And speaking of experiencing it in person, Daniel, we've done some kind of fun guest segments before, and you've helped with most of these.
Yeah, definitely across the years. I've been helping out with Allspace for the last 11 years, and so we really kicked it up a notch this year, or this past year, in terms of special segments. As you can see on the screen, where we showcased a lot of brand new segments to better showcase some of the science, as well as kind of put a pretty spin, and pretty nice spin, as to why this is important to showcase to the public. And so you can kind of see on the side when we're celebrating our 90th anniversary of Griffith Observatory, you can see that we did a very special All Space Considered for that, where we also did segments where we presented information as we were in the 19th.
Time travel episode.
Yeah,
it was a time travel episode.
That's the blue skies you're seeing there. Laura May and others actually performed some music live. It was pretty cool. Yeah. So we've done a lot of unique segments in addition to just presenting the news straight, but we've also covered the AAS meetings, like this 248th meeting in Pasadena. And over the years, we've had some interesting ways to present.
That we have. We've extensively covered AAS for many, many years, and oftentimes we've covered him, again, as part of a special segment. You could see we actually had our own award show that we called the Golden Griffiths, where we actually awarded trophies in honor of some of the headlines from the AAS. Of course.
And those are little Colonel Griffith bobbleheads that are on, anyway.
Little Griffies for short.
They're floating around out there somewhere. Look for one on eBay, maybe.
As we transitioned over through a remote show during the pandemic, we also looked at AAS through that lens until we came back and reported on AAS headlines as part of our normal show before going back to doing special segments like my personal favorite. We did a tier list episode for AAS 245, which we were very proud of that. A card flip game for AAS 246. And just this past February, we did our show reflecting on what we experienced attending AAS 247 in Phoenix.
Yeah. Now, of course, covering the AAS, we have to bring it to the public somehow. And oftentimes people love to call it the Super Bowl of astronomy, but I think it's more appropriate right now to think of it as the World Cup of astronomy, right? Yep, that's right. So now we didn't have time, of course, to go through all of the press releases, all of the science that was released in this meeting, but you can see these are all the teams playing in the World Cup. But next month, we will take headlines, we'll take discoveries, and we'll break them into some groups, and we'll have them, I don't know if we'll really have them fight it out because all the results are terrific. We don't tend to disparage anybody. It's not somebody's better than somebody else, but we like to show off what was told at the meeting and do it in a fun way. So we'll see how we make all this work, but we'll do something fun next month, so stay tuned for that. I do want to point out that it is Black Space Week, Black and Astro, that is a community of astronomers they exist to make sure we promote Black astronomers, and it is a grassroots organization that is out there to try and make sure that there's support for what they're doing and get the word out that things are happening. And We try and support them as we can. We appreciated being invited to their dinner at the winter meeting, which was terrific, met some great people. So I just want to show what's going on this week. And if folks are watching the episode live, you still have a little bit of time. There's some things happening on Thursday, Friday, and Saturday, as you can see. These are online events. You can register from them. And their theme is Voices of a Shared Cosmos. If the universe is a symphony, we are the conductors, the composers, and the audience all at once. Across 7 days, this celebration continues to highlight the shared cosmos. So I very much like their theme, and I encourage folks to register, and you can do so at that web address that's at the top of your screen there if you wish to participate. Well, in our space news, I want to kick it off with a goodbye to the MAVEN spacecraft that was at Mars. MAVEN launched back in November 18th, 2013 from Cape Canaveral on an Atlas V, and it headed off to Mars, arrived there on September 21st, 2014, and its mission was designed just to run for a single Earth year. So that's not even a whole Mars year, of course. Now, it was supposed to study the Mars upper atmosphere, how the solar wind strips away the atmosphere. We were supposed to learn how Mars's atmosphere was transformed from something warm enough to have liquid water on the surface to something that today is a barren desert. It outlived its primary mission by a full decade, so we were able to get over 10 years of data from MAVEN, which is just extraordinary. Over 800 published publications. Unexpected loss of signal occurred on December 6th, 2025, and finally the spacecraft was pronounced missing and gone, so we say goodbye to MAVEN. However, it was the only spacecraft that could simultaneously take measurements from both the sun and the Martian atmosphere at once and see how the two were affecting one another. The MAVEN mission discovered aurorae on Mars and discovered that unlike Earth, that you can get proton aurorae, but only near the poles, they can happen all over on Mars, everywhere. So it's a way we can learn about Earth by studying other planets as well. And it also simultaneously measured from 3 instruments on board the spacecraft: the solar wind ion analyzer, the magnetometer, and the neutral gas ion mass spectrometer, and was able to determine that, believe it or not, this is a really fun result, that it was high-speed charged particles coming into the atmosphere that are preferentially knocking out lighter ions. So you have ions of atoms that are in weird proportions. The heavier ones, there are too many of them. The lighter ones are missing. Well, what happened? It's kind of like jumping into a swimming pool. If I were to jump in and do a cannonball, and let's picture if you put a bunch of rubber duckies on the top of the swimming pool and a bunch of, well, I don't know, marbles down below. The marbles are going to sink to the bottom. If I cannonball in, my odds of knocking out a ducky are pretty good. My odds of knocking out a marble from the bottom are pretty low. The heavier atoms are lower in the atmosphere in general, and the lighter ones are higher up. So the lighter ones are more preferentially knocked out by these high-speed particles. MAVEN was the only spacecraft that could measure all of this at once, and it took 10 years of measurements to see this happening. Now, why is this important? Well, Mars, again, lost its atmosphere. Earth's magnetic field protects us. But if it starts to fall apart, we need to know what we might be facing, and it's a great time to study it. So MAVEN did some really amazing work. It was able to watch dust storms and see how those dust storms affected the atmosphere. It turns out when you have dust on the ground, more water is elevated into the atmosphere and water loss increases. So these dust storms make the problem worse for Mars. It loses water faster. It was part of the Mars Relay Network, so we're losing a piece of that. It was part of our communications network for the other spacecraft and rovers that are there. So MAVEN will be missed. MAVEN was a really terrific spacecraft that did amazing work, and we're learning a lot about Mars from it. And I'm sure we still will. We know as scientists that data, they are still there, and we will continue to analyze them. Moving on to another quick story, I decided to had a little fun with AI, of course. This is an ode to that t-shirt with the 3 wolves howling at the moon that was popular for a while as a meme, but instead of 3 moon mass primordial black hole, what is going on here? Well, this was a paper that came out that a lunar mass primordial black hole microlensing candidate in the Milky Way halo. That's a lot of words. So for those of you watching at home, what we're talking about is we've hypothesized that primordial black holes might be created in the early universe. Maybe. maybe during the time of inflation, but we're not sure. We've never seen them before. Well, we can use gravitational lensing, like you're seeing here. This is a galaxy that's lensing a background object, making that arc. Gravity can bend light. Well, if you have a black hole pass in front of a star, that starlight will change its brightness as you measure it. You'll get these little spikes in brightness, and you'll get sort of an increase, and then a decrease over time. I'm gonna wave my hands around. Now, we've been looking for these, and we've seen objects do this. We've seen microlensing events, but we've never seen one from a black hole that is so small. It only has predicted mass of 3 lunar masses. And Phoebe, right there, the little star that was brightened and darkened, it got brighter and the neighbor did not. So this was not an effect that the entire field got brighter. It isn't an instrumental effect. It's not a camera effect. Only one star got brighter. And it did so, when they modeled it, it was a 3 lunar mass black hole that would fit it. Now, it could be in the LMC, it could be in the Milky Way, it could be in the dark matter halo. There's a little bit of uncertainty in there, but you can see the lines overlap here. I love showing the data, and people can go, oh, I believe that now, where the astronomers are going, is that a 2 sigma line, or is that a 3 sigma line? Yeah, it's only a couple of sigma result, but nonetheless, this is the first possible detection of a primordial black hole. We need to find more of them. If these are out there and they're real, we'll see more. If this was something else that happened, well, we'll wait and see. But this is the first time this has been kind of predicted. Now, there is another thing that happened recently in the skies.
Little closer to home.
Closer to home, but it was a brightening of sorts.
It was observed also by quite a few people. This happened over the skies of North America. So you can see here, right in that little circle, we've got a big meteor. But do we have the sound on this?
What the was that?
Yes, we do have the sound. So we also have there we go.
Oh, puppy.
Scary. So this is a dog named Chicken, apparently.
Chicken's a little chicken.
Who also apparently a fan of meteors. So hurrah for dash cams. This is actually the only photo we have of this bolide, right? These are usually these larger meteors. But more importantly, we had a lot of reports. So this is to remind you that the American Meteor Society is out there. And so anyone can go and log a report on there. So they received over 90 reports from this very event. So it happened on May 30th, just last month, at about 2:06 p.m. And you can see in all of those listings that it was visible as far north as Canada. So an international meteor. And of course, when you fill out these forms, you can give the direction, you can give how long you saw it last in the sky. So as much information as you can get is very, very useful for figuring out quite a few things, quite a few parameters. And here are all of these sightings on a map. So pretty extensive range. And there was even a sighting from an airplane. So I'm guessing this person saw it out the window, and right here you can see there's a little bit of the trail that was left over. So these can persist for up to an hour, and what you're seeing is really just vaporized debris and ionized gas that was left over by the passage of that meteor. Now, it might seem to us on those videos like it was just a fairly bright, but fairly average meteor, but it had that sonic boom, and the reason for that is that it was traveling faster than most meteors. Now, meteors are usually around 45,000 miles per hour, but this one was going about 75,000 miles per hour, and it released the equivalent of about 300 tons of TNT. So that's why it was actually caught on the GOES-19 satellite with a lightning mapper, and that's what you're seeing here. So it fragmented at an altitude of about 40 miles. And this fragmentation is very interesting. It's the topic of lots of important research. We actually spoke about this in our January episode with the findings around CX-1, which landed in northern France, because it changes how the mass is going to land. That fragmentation can create, as we saw, I think in 2013 in Russia, the Chelyabinsk. So we had quite a lot of damages there. And so these are very, very important data. So if you see bolides, please log them. Now, its main mass was about the mass of a washing machine, about the size, sorry, the size was about that of a washing machine. You can see it. Unfortunately, we didn't get an image, but here it is landing on Earth. And it,
A washing machine drone, that's what I want.
right?
I love it.
And so it weighed a couple tons, but parts of it may have fallen on land, believe it or not. I presume the meteorite hunters are already out there. And the rest, the main mass, probably landed in Cape Cod Bay, which is somewhat good news because we might be able to recuperate it. One of our colleagues who's a meteorite hunter, he's probably, I'm sure, following what's happening there. But it is about 100 feet deep, or about 30 meters deep. So whether someone goes there with trawlers and, I don't know, metal detectors, but if they do, they might find some incredible meteorites. So some of it may have survived. We think the piece that might have survived should be around 20 kilos, so about 40, 50 pounds. So we'll see if they turn up something.
Yeah. Be pretty exciting if they
And there were quite a few sightings recently. I think the public was relatively alarmed at the amount of bright bolides and meteors that were in the skies recently, but they're unconnected.
They are unconnected. In fact, I'm going to show one that's completely unconnected. This one's from 2014, actually. Well, this says May 2024. I don't know why I was thinking 2014. 2024. It's still a couple of years ago. Time is all smashed together, as I think others are experiencing too. This was Milena Refachos, I think is how you say her name, video from Portugal. And she was just filming herself. And yeah.
Probably the best video out there of
Just love her reaction. It's so honest, so true. You know, she's looking happily at the camera and then just like, oh my goodness, what is going on? Yeah, imagine seeing that. I think things like this may have inspired a lot of us to become astronomers, to go do what we do. So, but webcams being in more and more locations mean we're catching more things like this as well.
this was very recent.
Yeah, this was May 25th, 2026, at 10:33 local time, and this was in the Philippines, the MAVEN volcano. That's a very, I mean, it's a volcano erupting all the time, and if you just watch this, you can see the lava coming down, which is fun enough. I mean, I love that, and all of a sudden you get this bolide coming next to it. And then finally, this was in Michigan, in a 14-second long fireball over southern Michigan. It was seen throughout the Midwestern states as it came in, and these were not related. They're coming in different directions. They just happen to be happenings. The public was wondering about that, and like Laura May said, go to the American Meteor Society. You can report the meteors here. But let's clear up a little bit of terminology for our audience at home. Asteroids, they're generally large, rocky things that are floating around out there. Comets, they're cold, solid. They tend to have more ices in them. There is some overlap between asteroids and comets, we've learned. There are asteroids that act a little more like comets and comets that have a little bit more rocky material in them. So this is a field of research that's going on right now that we're learning a lot more about. But when these things get close to the Earth, and if they're small enough, a small asteroid we will call a meteoroid, and that's if it has a chance to come into the Earth's atmosphere and form a meteor. The glowing light trail we call the meteor. Now, a fireball is one that's brighter than about Venus or so. It's bright, looks like a bright planet coming in. A meteor shower is when you have a bunch of them happening in the same night, and they tend to be associated with the debris from a comet. Then finally, what we've been seeing in some of these videos are bolides when they explode with a flash at the end of them. And those are much larger meteorites, things the size of washing machines coming in, basketballs, things that are larger. And then the meteorite is the rock when you can pick it up on the ground here at Earth. So that clears up all the terminologies for you. Now, I did a little search at the meeting. I wanted to see how many people were talking about meteors, and I'm sure there was some meteor research going on and people talked about it here. But when I did a search for meteor, meteoroid, meteor shower, they all came back with no records found for this meeting. And I thought, well, that's a little strange. Normally there's at least some papers. There's a poster or something going on. Well, next month, July 6th through 10th, is the Asteroids, Comets, and Meteors Conference. That was the first conference that I actually attended I worked it. It was right after undergraduate. It was in Flagstaff. This one's in Poland, a little further away. I don't think I'm going to be able to get there, but hang out just a month and you're going to get all sorts of papers about meteors and comets and asteroids, and we'll report on it in All Space Considered. So stay tuned for that. Now, I do want to point out some upcoming meteor showers that are happening. The Perseids are the ones to circle on your calendar. They're going to have about 100 meteors per hour. The moon is pretty much non-existent that night. You don't want to have the moon in your way. So make plans to get out there and watch the Perseids this summer. It is the best shower of the year, probably. There are some other neat ones in there too, of course. The Geminids are usually bright, but the moon, well, it's 21%, not terrible, but it's cold. Who wants to be out in December? Anyway, you can always search for these. You can plan your meteor shower trips, and it's a lot of fun. Well, now it is time to welcome up Ginger Rose. So Ginger Rose Brucker, come on up. Thank you so much. Thank you, Daniel. Yeah, Ginger Rose is one of our producers of the show, one of our science communicators, and every month you bring to us some beautiful astronomical images.
Yeah, I'm really excited to show these images here. So this first one, you might all recognize from Monday's press conference. This is Chandra, Chandra reveals supernova remnants in M83. And I just love this picture. It's so beautiful. You have all those amazing colors. And this galaxy, M83, is located just about 15 million light years away. So pretty incredible. And then this next one, what do we see in the difference between these two? What do we think? Different galaxy, same galaxy?
Looks the same.
Yeah, it looks a little zoomed out, so it's a little farther away, but it's actually the same galaxy. So this is an amateur astrophotographer, and he took this picture, and you can see still a lot of the color, and you see a lot more of the yellow brightness in the center. But yes, so pretty incredible getting to see the difference between these two images.
In fact, the dust lanes might look a little more prominent in the amateur photo.
Yeah, that's right. And you really see why they call it the Starburst Galaxy, right? All right, and then this one, so this is celebrating the birth of new stars. This was a VST released on, I think it was June 8th, and they are actually released this one celebrating their 15th anniversary of the telescope's first light. And so this is GUM 10 and GUM 11. Anybody have some chewing gum? So this is in the southern hemisphere, actually. And so that GUM 10 is the brighter nebula that's dominating most of the image on the right that you see. And then GUM 11 is that smaller part on the bottom. But just really an incredible image that you see here. And then here we go. What do we think? Different? Same? The orientation is a little bit different.
It looks pretty good.
Yeah, so this is another amateur astrophotographer image. I found this one on Astrobin. So for those of you who may not know what that is, Astrobin is a website for astrophotographers, amateur astrophotographers, and you can upload all of your photos there with all of the information, like the exposure time, the integration, and it's a really neat, fun place. You know, if you're ever doom scrolling on Instagram, just go to Astrobin and look at pictures of nebulae and galaxies. It's a lot of fun. And then this one kind of threw me out. This is a Hubble image of a lenticular galaxy, and it's NGC 1266. It kind of it reminds me of like the egg, what is it, the egg nebula galaxy? Just the shape of it. Lenticulars are lens-shaped, so you kind of see more of that bright central bulge, and not so much of like any arms or anything, but a lot more dust around it, so you can kind of see a little bit in the center, but not as much as we're typically used to. But this one kind of caught me off guard because I could not find any amateur astrophotographers that had this galaxy, and I think it's because of, you know, how far out it is. It's really hard to capture. So here's a challenge for everyone. If you are an astrophotographer, please take a whack at this one.
Yeah. Let's see what you can do.
Yeah, yeah. And then we probably all most recognize this one. This is our famous Hubble picture of the Orion Nebula. So this nebula is about 1,500 light years away. And this image alone is 520 Hubble images, and they were taken in 5 different colors. You can see a lot of different colors here. But this mosaic covers approximately, I think it was, the size of a whole entire full moon. So the Orion Nebula itself is about a magnitude 4. So it's a pretty bright, good astrophotography target for like amateur astrophotographers. I would say like it's definitely one of the top ones. You've probably photographed it too.
Especially in light polluted skies. It's one of the few you can even see through a telescope.
You can see it with the naked eye actually on like a very dark sky. Sometimes.
For those of you who still have good vision, I don't know.
Yeah. Although we are losing that, unfortunately. And then here we go. So this is also, what do we think? Is this a Hubble, James Webb? You guys kind of probably get the flow of this talk here. It's no longer a surprise. But yes, this is a astrophotography version of the Orion Nebula. It was actually taken by the LA Astronomical Society's robotic observatory. And this one was taken by, I think, Karim El-Mahmoudi. And it's about 3 hours of exposure in visible light on this. So around 3 hours collected, stacked, and processed. But look at the detail in this. Like when I first saw this, I was like, oh, it's James Webb or Hummel. But it was actually
There is processing, obviously, I'm guessing, a little bit.
Yeah, especially with that color. And you see those like filaments and the strands. It's incredible, just very beautiful. And then this one, I'm going to start segueing into the astrophotography contests that I'm going to talk about briefly. But this is an image, it was a Dark Sky Award winner, and this is the Large and Small Magellanic Clouds, and he's holding a mirror, so you see that reflection. It's just such a beautiful image, a lot going on in there. And this is just, a reference to improving or keeping our dark skies and how important it is to have our dark skies.
I've got thoughts about this image. There's no way he stood there and held that the whole time. It must have been propped up, and then he ran out there, got himself in the photo, and then left. Because exposure time to capture, that's got to be long. This is a crazy impressive image.
Might be a
Especially with the
composite,
foreground.
I don't know, but it's cool.
That's what I'm assuming. It's the foreground and then the.
Yeah. Do you know where it was shot from?
I don't. Somewhere in the southern hemisphere.
Bolivia, maybe. It looks maybe like the Salar de Uyuni.
I don't. Yeah, the lake. I don't know the lake's name, but
Amazing.
it's pretty beautiful. And then I had to throw this one because
Classic.
I know astronomers. We're all cat people here, so had to throw this one in. The Moon and Cat by Leo Colvin, who is also an amateur astrophotographer. Takes a lot of pictures of the moon and the night sky. And then this one was really interesting. This is, of course, over a series of a few different shots. And this is the moon, Venus, and Pleiades. So the Pleiades is next to the moon. There's like these little dots. And this was taken on April 19th of 2026 across a southern Sicilian night sky. So it's just really beautiful. I think it was also on Astronomy Picture of the Day. So as one of their astronomy pictures. So this next one is the Venus and Jupiter conjunction from June 12th. Did anyone get a chance to see that? Yeah, awesome. All right.
They weren't that close, though. I mean,
Yeah. Well, they look close here.
That's true.
Compared to these huge rocks.
That's true.
So I thought this was a really neat shot just to see them. And then, of course, I had to throw our famous David Pinsky, who always sends us the most beautiful pictures of the sun and the moon. So this was taken by, June 9th with a Lunt 50 solar telescope. And here we are to the astrophotography contests that I mentioned. I'm really excited to talk about these because if you're an astrophotographer or you're just getting into it, this is really open to all levels, even iPhone astrophotography. So submit your photos to this contest. If you go to their website, you'll be able to fill out all the information for the contest. I think it closes June 22nd, so coming up here. And then there's one more. This is the Dark Sky International contest. So another one that just talks about preserving our dark skies and the effects of light pollution. And there's a link for that. They have 9 different categories that you can submit your images to. So I know you mentioned you're going to submit some pictures.
Well, yeah, everyone should listen. Even if they have an iPhone category, especially, everyone should submit things.
Yes, please do. So yeah, that concludes everything. Thank you.
And one more, though. Let's forward one more slide.
Oh, yes.
We want you to send us photos to us.
Please, yes.
We want to show off your work. We often show David Pinsky's. He needs some competition. So if you think you can do better than Pinsky or better than Anthony Perkic, a couple of our regulars, send us your pics. We'd love to show them.
Even if they're not your own pictures, maybe things that you saw or a talk that you went to that you thought was really neat, you can send that to us too.
And your research images. We have a lot of researchers here today, so please send us some of your images. Occasionally, some of these are very interesting. So.
Yeah.
Absolutely. Well, thank you so much, Ginger, for joining us. Appreciate you. Yay. Well, now we'd like to welcome up Jared Head to talk about Out to Launch. Come on up, Jared. Jared's another one of our science correspondents, producers of All Space Considered, and all-around rocket scientist. So welcome, Jared. You got anything interesting for us this month?
Yeah, a few things. Luckily, no explosions locally here in the convention center, but we are gonna have one to talk about. With it. But I do want to start off with a launch, because I call it Out to Launch without having a launch, and this is Flight 12 of SpaceX's Starship vehicle, still in the testing phase. This was the first flight of their version 3 Starship, which is a little bit taller, 404 feet tall, and putting out about 20 million pounds of thrust, almost 3 times the Saturn V, and I'm just blown away by the shock waves that you can see visibly there. I just like seeing that compression coming out is stunning. I haven't seen that with a launch before, because this version with uprated engines is putting out a lot more power. Now, there were some issues during the flight. So this is the little thing that indicates all the engines. They did lose a Raptor engine on the booster. And then here at booster separation, you'll see that booster, it's pretty spicy when it separates and does its turn and burn there. And in fact, it's so spicy that it might have caused some engines to fail. So take a look at this right here. And poof. Not good. So, and then also on the actual Starship upper stage, they lost a Raptor vacuum engine, which we can see right here at the bottom. There that goes, letting go. And of course, because those engines on the Super Heavy booster weren't particularly working that well, only one lit and then shut down immediately on their landing in the ocean. So it ended up going into the ocean at over 900 miles an hour. So I don't think it made it. But the Starship vehicle did make it to orbit. It did have several Starlink mass simulators on board, and those simulators, several of them actually had cameras, and then downlinked the video in flight while they were still, going through the process of testing it. So this is a view from one of those Starlink mass simulators of the Starship vehicle in orbit as they're heading out. So we could see details like that big circle right there is actually going to be a part of the in-flight on-orbit refueling system. We could see things like the ice from the cryogenic propellants, probably the liquid oxygen, like a nice stripe of it right there on the left side of the screen. And overall, it looked like a pretty clean flight for what they needed for this first flight of a version 3 Starship Super Heavy. And then on entry, they actually did some pretty tough testing on it. They pushed it to its limits, and we'll actually see one of those limit pushing tests right here where they put the flaps out all the way out. To come back in, and then tested moving those back and forth very rapidly to push the physical limits of what a Starship could handle. This next shot has got a really great view of that the aft flap, the flap at the bottom of the vehicle, moving back and forth to really subject it to some serious forces. And you'll notice as well, no burn-throughs on this re-entry as well, which is great. Eventually it came time to land, and it looked like one of the engines did not light as planned, which ended up causing the Starship upper stage vehicle here to pirouette as it came in for a landing. And then SpaceX was kind enough to keep the feed going as Starship landed in the ocean, the Indian Ocean, and then tipped over and did what a rocket does when it tips over, which is go kaboom. So yeah, it's kind of like a soda can. If you tip it over, it can explode, and that's a really big fireball. So.
Is this on the Californian coast?
No, this was out in the Indian Ocean, so nobody was around, thankfully. But they had a pretty good test flight. They got to work on those engines, those Raptor engines, the uprated ones, and see what they can do to kind of help fix that. Now, one fireball leading to another. Unfortunately, our friends at Spaceflight Now were at the Cape in late May, and on May 28th, Blue Origin was about to do a static test fire of their New Glenn rocket, which is about the size of a Space Launch System rocket, so 300 feet tall. It's big. And unfortunately, that static fire did not go according to planned. So, yeah.
Oh, my.
Yeah, it was a little bit of a big explosion there. And actually, this is the largest rocket explosion in the history of the United States. So, but this
not the world.
But not the world. This is actually the 5th largest rocket explosion that's ever happened. It was about 1.2 to 1.4 kilotons worth of energy going off, or as a friend noted, basically like a small tactical nuclear weapon.
Wow.
So yeah, that was very intense. And I can't remember if this has audio or not. We'll all find out very shortly if it does or not. You can see that plume was just absolutely massive. This is a way to demolish your launch pad in a hurry, if you need to. Blue Origin, as you can imagine, their launch complex 36. There we go.
Here's the boom.
Kaboom. It was destroyed. The lightning towers fell down. The actual launch tower had a tremendous amount of damage. But Blue Origin says that they're actually going to be able to fix that all by the end of the year. So we'll see if that's possible. I kind of don't believe that.
There was discussion about how that might cause delay on other missions going out.
Yeah, the Artemis missions are reliant upon both SpaceX's Starship Super Heavy vehicle working correctly and Blue Origin carrying their lander on their New Glenn rocket, which just exploded and destroyed its launch pad. So, no biggie. So, welcome to aerospace. Delays are sort of how it works. So,
what I found most troubling is this happened right on the heels of the press conference announcing the accelerated schedule to get back to the moon, and we're going to land 2 landers, we're going to do all these things, and this is one of the vehicles that was supposed to help get us there, right?
Yes, it is. It was actually the mission after this was supposed to fly the Blue Moon Mark I lander, which is the uncrewed cargo version of their lander that they're going to develop for humans to land with on the moon. So this was some poor timing on the part of that. But welcome to aerospace.
Where was the biggest explosion?
The 4 biggest explosions were the Soviet N-1 moon rocket, which unfortunately it was a huge rocket. It was larger than the Saturn V, more powerful than the Saturn V, but also prone to blowing up. So all 4 of its test launches exploded.
Wow. Did they stop after that?
Yes, they basically said we're done with the moon program at this point. So from 1969 to 1974 is when the N1s flew. Well, I should say flew until they turned into a fireball. There, and those were the largest. They were about twice the size in terms of propellant load with New Glenn, so they were gigantic with that. And then I did want to point this out too, which is that it's a little slightly unscientific, but it is something to consider with how big this explosion was, which is that it did register on the USGS seismographs as a 2.5 earthquake. So it was big. So, and I enjoy the fact that, one, it's really far away, but also I love the depth measurement on there is 0.0 miles. So you don't often have an earthquake at the surface, but there you go. So that's what that was like. And then very shortly after that, too, we had the announcement of our Artemis 3 crew, which is now most certainly going to be flying later than they were expecting to. And a really solid crew here. The gentleman seated on the right is Randy Bresnik, who is the commander. So he's a veteran of a space shuttle mission and an expedition to the ISS. Seated on the left is ESA astronaut and Italian Space Agency astronaut Luca Parmitano. He is going to be the pilot of the mission, and he's He's a veteran of 2 expeditions to the space station. Standing on the right is Frank Rubio, who is who actually has flown the longest mission for an American at 371 days continuously on board the International Space Station. So he's going to be Mission Specialist 1. And then over on the left is Andre Douglas, who is going to be flying his first mission. So he is the rookie on this flight. And a very solid group. Almost all of them have an extensive amount of spacewalking experience, which that is what Artemis 3 is all about. They're going to be docking with the landers, which they announced they're going to be docking with both landers, both SpaceX's Starship and Blue Origin's Blue Moon Mark II, and then transferring into them to kind of take a look around with them. So it makes sense to me to have people on board who are extensively trained in how to do extravehicular activities with that. So we'll be rooting for them whenever we find out their launch date is, which is not going to be anytime soon. It was set for summer next year, but and NASA Administrator Jared Isaacman says that they're going to hit that target, but I don't think so.
Well, I'd like to hope that this is a sign that the next crew will be all women, though, right? It is Artemis.
I'm sure.
Yes.
I'm sure it will
hope.
be, right?
I definitely am on board with that. So, yeah.
This is the 44th, I think, all-male crew.
Yes. And there are some rumors as to who the astronauts are going to be for Artemis 4, and that there is going to be at least one woman who will be going down to the surface of the moon, and possibly a woman commanding the mission. So looking at the women astronauts who are in the NASA Astronaut Corps right now, the ones with the most experience, a lot of good choices, and I hope that we get some more women on that crew.
Cool. All right, well, now it's time for our Mostest. So this is our section where we try to highlight, occasionally poke a little fun at some of the amusing headlines and sometimes more serious headlines about discoveries. Now today, our discovery, or rather our Mostest, is down on Earth. Anyone here been to the Grand Canyon National Park? A couple of you? Okay, quite a few of you. So you're all astronomers. You might have gone there with a little bit of knowledge of what you might see there. For most people, it is a place of geological wonder. You get to see incredible Earth history, but it is also a place that has put tremendous effort into its dark skies, into preserving it. They are now about 96% compliant to dark sky initiatives, so many people go there to see the Milky Way. And just last week was the 36th annual Star Party. It really does help to actually see it in the daytime because it is absolutely enormous, the amount of scopes there. It is quite potentially the biggest star party in the world. If you're aware of one that is bigger, let me know, but it is the Mostest star party, I guess. And they turn the entire place, or at least the entire area of the star party, into this beautiful, enchanting astronomy wonderland. It is the one place where I guarantee you will not see anyone with a white light ruining your eyesight for a couple of hours. And the preliminary stats on this year, they had about 10,000 visitors. Now they had about 150 volunteer astronomers. And keep in mind, the Star Party lasts over a week. So for that whole week, every single night, you get to go. It's usually in June. Anyone can come, and they can actually look through these 150 or up to 90 telescopes per night. And they had about 500 visitors per twilight talk, so every single night. We had one of the former Grand Canyon astronomer in residence, or the current Grand Canyon astronomer in residence, give talks. So I gave a talk on interstellar objects. And there's a lot of fun going on. There's, of course, a lot of glow in the dark. It's very 90s. Lots of people dress up. And there's also just, it is a really extraordinary event. There's a lot going on. There was a huge meteorite gallery with some, honestly, very extraordinary pieces. I recommend you go. And of course, there is a lot of astrophotography going on. Nowadays, all of these smart telescopes, many people had screens. These people were shooting the Whale Galaxy, absolutely beautiful object. And they even set up a Milky Way photo booth. So the Grand Canyon Conservancy set this up, and all night long we had people coming up and getting their picture taken with the Milky Way. Almost clear skies pretty much every single night. And again, photography that is also respectful of the night sky. But of course, The major attraction is looking through these scopes. Now, this is a view through a night vision eyepiece. These are pretty costly toys, but you can actually connect them through a telescope. And I was absolutely amazed to get to see something. We saw a lot of nebula. You are, again, in a very dark sky. But I got to see this. Anyone know this image? Anyone familiar with this absolutely super famous image? Probably one of the most famous Hubble images. This is the Pillars of Creation in the Eagle Nebula. It came out in 1995. And here it is. So this is shot through my phone, believe it or not, right through the eyepiece. So this night vision eyepiece, it gives a little bit of sparkle, and an H alpha through a 28-inch Dobsonian. And you could actually see the Pillars of Creation with your eyes through this eyepiece. So absolutely extraordinary. It is the perfect sky to look at the Lagoon Nebula, Trifid, everything you can imagine. I did a little experiment myself. I shot the Omega Nebula. This is just about a half-hour exposure, M17 through a Vaonis. So highly recommend that you make it out. It was the 36th year this year, and next year, hopefully even bigger, and it is really an extraordinary event.
Yeah, well, thank you for that, Laura May. Well, we are to our guest segment now, so we want to welcome to the stage Stephen Hummel. Stephen Hummel is the Dark Skies Initiative Coordinator for McDonald Observatory, which is part of the University of Texas, Austin. His work focuses on preserving dark skies. He's a member of the AAS Compass Committee, which is the Committee for the Protection of Astronomy and the Space Environment, and a former Grand Canyon astronomer in residence. You're an award-winning astrophotographer, one of the most prolific sprite photographers, and these beautiful and elusive red upper atmospheric phenomena, if you don't know what those are. But everybody, let's welcome Stephen. Thank you. Welcome to the program.
Pleasure to be here.
So you were actually quite involved also with a couple of talks here that happened at AAS. Can you share a little bit about what you were talking about?
Yeah, so, well, fittingly, one of my eye posters was talking about dark skies at the Grand Canyon National Park. So I was fortunate enough to serve as Grand Canyon astronomer in residence last year. And what I did as part of my time there was take measurements of light pollution in the park at 5 different places in the park, mostly on the south rim, but I was very fortunate to even go on the north rim, which was closed in February. So I was the only person on the north rim, which was really cool, aside from a couple of people staying at the lodge, which then later burned down shortly after I left, which is really sad. But I measured light pollution there, and actually this is something the National Park Service, until recently, did fairly routinely, so I was really following up on work they did. So obviously the Grand Canyon has incredibly dark skies. It's this famed dark sky park, but let's put a number on it. How dark is it really, and how has that changed? And well, what we found is that light pollution there has gotten worse, which is perhaps not surprising. That's kind of the global trend. But from 2015 to 2025, it roughly doubled from the popular viewing spots. And what was surprising to me was, some of that light was coming from within the park, but very little. Most of the light pollution there was actually from Phoenix and Las Vegas, which are over 150 miles away. They're really far away. And if you've ever been to the Grand Canyon, there's a good chance you flew into one of those cities and drove over there. And if you ever do that drive, it's a long drive. But that is where a significant portion of the light was coming from. The good news was that Flagstaff, which is a pretty close city, it's about roughly 100,000 people or so, had very, very little impact, mostly due to their extensive campaign to reduce light pollution. So
Well, that's where Lowell Observatory is, of course. So they work very hard to have lighting that's downward and not in the sky. So I was going to ask you, what can people do if they want to help preserve dark skies? What can you do at your own home? What can you lobby for in your city?
Yeah. Well, that's a great question. So, light pollution is one of those environmental issues that is actually really easy to fix, or at least the solutions are easy. It's really just a scale problem. It's a collective action problem. But the solutions are simple. You shield the light. You aim it down at the thing you're trying to see. Don't blast the light into your neighbor's house. They probably don't appreciate that. Don't shine it up. The birds don't need it. Just aim it where you need it to be on the ground, not visible from above or off property. Using a lower intensity, a lot of people think more light equals more visibility, right? No, no, not really, actually. You can have too much light, and you can actually make it the adjustments between differently lit areas too harsh if you overlight. So lower intensity, just enough to see the task at hand. Using a more amber color, that's something Flagstaff takes a lot of pride in, actually. In other areas, too, they use a more amber tone that doesn't scatter in the air as much as blue-rich light does. And then turning lights off.
And you've spoken a little bit also about, you know, some fairly large threats to all, whether it's astronomers, whether it's normal people, everyday people. What are the current larger threats that we're facing in terms of preserving the dark skies?
Yeah, so a second talk I gave on Monday here at AAS was on threats from above. So light pollution from the ground is a big issue. It's a big environmental issue, not just for astronomers, but for wildlife too. But the solutions are pretty straightforward. Threats from above are increasingly satellite constellations. Now, this is a really hot area of discussion right now. But in particular, there's one satellite that really got astronomers riled up lately. This one proposal from a company called Reflect Orbital. So the AAS actually submitted a formal petition to deny this satellite. This is something kind of unusual for the AAS to do. Well, what is Reflect Orbital? You may be wondering. That got such a visceral reaction. It's giant mirrors in space to reflect sunlight back at Earth at night intentionally. So you can hire them for your illumination. It will be, provide a roughly 5 kilometer, 3 or 4 mile wide spot of light, but it would still scatter. So it would be visible from hundreds of miles away.
Yeah. This feels like a horrible idea to me, so I encourage you all to speak out against it, and we need to stop this. So, well, thank you for your work in protecting dark skies, the work you're doing here on the committees, the AAS committees, and how can people get involved locally? Who can they reach out to other than doing their own work? Is there something they can join nationally, or how can we bond together?
Yeah, there is a global nonprofit, Dark Sky International, has a website with lots of resources. And if you're in Texas, like myself, we also have local chapters like Dark Sky Texas or McDonald Observatory. We do a lot of work in West Texas. There's likely an astronomy club or a Dark Sky chapter somewhere near you, or even internationally. So there's lots of ways to get involved.
Which here is Los Angeles Astronomical Society. So if you're local, there are people committed to this cause in particular. There's a petition being circulated right now and a variety of other measures. LA City actually is preoccupied with that and is looking into it.
You really are. Well, thank you so much for joining us, Stephen. Appreciate you telling us about this. Let's thank Stephen, everybody.
Thank you.
Our next guest is Allyson. Bieryla, I'm going to mess up her name because I consciously tried to learn it, which of course means I'm going to mess it up. Harvard CFA, observational astronomer who works on discovering and characterizing of exoplanets. But in addition, Allyson is the chair of the CARE Committee, the AAS CARE Committee, brand new committee. You're the chair, and CARE is the Committee for the Accessibility, Rights, and Equity. So, Allyson, what is CARE? And by the way, I help out. I volunteer for CARE, helping us do some stuff just for clarity's sake. But what is CARE, and why is it important that we exist?
Yeah, CARE is just that. It's the Committee for Accessibility, Rights, and Equity. We've been around for about a decade with the AAS, and we're basically here to help make sure that those attending the AAS have a good and equitable experience. We've worked on things such as quiet rooms, making sure there's chairs available, microphones, working with the board and governance to make policies and masking during COVID times. So just trying to make sure that everybody gets what they need to have a good and equitable experience.
Yeah, a lot of people don't know, but while these meetings are very important to network, to meet people, they're not easy for everybody. Some people come to the meetings and they're incredibly energized and they can go about their day. Others need that quiet room. They need to recuperate. Others have disabilities that they need to have assistance. And in fact, CARE is going to join the Griffith Observatory Star Party coming up. And let me me skip ahead. I have things out of order here. Let me skip down, and we'll go back to our other one. So here's the CARE slide, and we'll put up, CARE is tasked with promoting the inclusion and equity and opportunity for disabled astronomers of all career stages. And on Saturday, in just a couple of days, up at Griffith Observatory, CARE has set up accessible astronomy for the Star Party. We're going to have a printer that will print some bump paper so people can feel astronomy. We're going to have some large screens so folks that can't make it to an eyepiece will be able to experience the astronomy. And we'll even have some sonification. So we're hoping to sonify the sunset. So as the light changes, you'll hear the sound change as well. So if you'd like to come up to Griffith Observatory and join us, you can. Anyway, this is what you were just saying. I'm sorry, I didn't have your slides there. I got them out of order. But I feel pretty passionately about this subject because astronomy is something that we could all enjoy. We're all in the universe together. We can all be inspired by it. So thank you for your work that you're doing here. And thank you for making these meetings accessible for everybody.
Do you feel that this is something that in astronomy, also in general, in the field, that we can do better at?
Well, absolutely. I think that's the important point. Like, accessibility is often an afterthought, and I think it's really important that we don't make it an afterthought. These are, if you come to the observatory or if you experience any of these things, it's just data. It's just interpreting data. And we're raised at a very young age to interpret it visually. But that doesn't mean you can't interpret it another way. And even a sighted person can experience data through sound or through tactily. And so I think it's an important thing.
Yeah, absolutely. And we should be inspiring students of all ages. So we should be helping schools get this sort of equipment, universities. So I encourage everybody to reach out to your institutions and engage this way. It would be really great. Well, thank you for taking the time to join us here on the stage and talk about CARE a little bit. Let's thank Allyson again. Thank you so much.
So it's a great honor now. We have our last guest, Dr. Dara Norman, the current and 50th president of the American Astronomical Society. She's also the deputy director of the Community Science and Data Center at the National Science Foundation's NOIRLab in Tucson, and her research focuses on the influence of active galactic nuclei on the evolution of galaxies. Thank you so much for being here.
Thank you for having me.
Yay. So, one of your last acts as president is to join us here at All Space Considered at the AAS.
Absolutely.
You've been president for a couple of years now.
2 years. The presidency is a 2-year term, but you start as incoming president for a year, and then I have another year as past president. So it's a 4-year stint. So my daughter started her undergraduate degree when I first started, and she'll be finishing up when I finish up. So
That's just fantastic.
that's the span.
What are some of the aspects you focused on during your tenure as president, as part of the society?
Yeah, so when I came into the society, it was June of 2 years ago. But the first meeting that I actually presided over was in January of 2025. We all know what happened in January of 2025. So immediately, my work was not exactly what I had intended to do when I came in as president. So we've done a lot of advocating for the science community broadly, actually, and trying to make sure that we do have enough funding to continue all the work that we're doing and continue with supporting early career folks in their efforts to be, full career astronomers.
And we spoke a little bit yesterday about some aspects of the American Astronomical Society that many people probably don't know about, which is that there are these smaller grassroots movements or community movements that are part of it. Can you tell us a little bit about this?
Yeah, so I think I and a lot of folks who are in the leadership of the AAS, we actually got started by being on those committees, like Allyson was saying, like CARE. But we have a lot of committees. We have something like 14 committees, and in fact, CARE is our newest committee. They just got elevated from being a working group to being a full-fledged committee about a year ago, yeah? A little less. Yeah, but there are a number of committees, and most of the committees are grassroots committees, so if you have an idea about something that you are passionate about or interested in. We have committees on education, on sustainability, on we have committees that support astronomers who are no longer in academia. If there's something that you think of and you don't know that there's a committee already, you can propose to the board to start a working group, for instance, and eventually we expect that you get things going and become a committee.
What are some aspects of the society that you'd like to see expand after you leave?
After I leave, well, we publish our own journals, our scientific journals, and so yes, you have images there of the corridors for our journals. So we publish our own journals, and we're always looking to make sure that our journals are healthy and that the science is getting out to the public and to all of you to know what's going on.
Do you have to break out fights between the people that publish in AppJ versus AJ, or has all that been worked
That's
out?
why we have the corridors, and that's why they're all so pretty.
They're also pretty.
So everybody, nobody feels like they're getting left out,
Certainly
right?
left out. But what I like about that is the publication office really is very supportive of astronomers to get our work out there. It's not free to publish, as we all know, but it is a community, and the AAS is there to support that. So despite my jokes, this is a very important thing that the AAS does.
Yep. Yeah, it's a really important part of making sure that our field is healthy and doing well. So we also, we own Sky and Telescope.
That's right.
And so amateurs who are interested, or even professionals, a number of us actually have subscriptions to Sky and Telescope, but Sky and Telescope is owned by the AAS, and please, get a subscription if you don't. There are great articles, great images in that magazine, and they're doing a lot more with the board now. So yeah, we're trying to make Sky and Telescope closer to what the things that the board is doing.
Well, fantastic. We have a little bit of time, a moment or two, if anybody has any questions. Any questions in the audience for our president? I'm not seeing anybody. Our at-home audience is like, I have one. Sorry, YouTube. It's recorded live on Wednesday, a day earlier. Well, I have a final question for you. As president, you've probably had a lot of duties, a lot of things to do. Are you itching to get back and do a little research, or do you have any interests that you want to get back and do? Because I know that you're at NOIRLab as well.
I'm at NOIRLab, yeah. So I'm at the National Optical Observatory in Tucson, Arizona, is my home base. And I took a sabbatical, actually, to be president, but now I'm back to work. And in fact, I see you have that I'm the deputy. I got promoted. I'm actually the director now.
Thank you for telling us.
For Community Science and Data Center. So I am looking forward to being back with my colleagues, and I'm really interested in the data mission of what the observatory does, and of course with the Rubin telescope, the Rubin Observatory coming online, we're going to have a lot of data available, and I'm really looking forward to seeing, how we parse out and use AI to help us look through those data and make new discoveries. So.
And by the way, that was just a class in understatement. We're going to have
A lot of
data, a lot of data. You're going to have more data than just about anybody else. It's incredible what they're going to have. Well, thank you so much for joining us today.
Thank you for having
and taking
me.
the time. Absolutely. Everybody, let's thank Dara Norman again. Thank you so much. Well, folks, thank you so much for joining us for tonight's All Space Considered. I want to thank all of our correspondents tonight, Daniel Perea, Jared Head, Ginger Rose Brucker. Of course, our guests we want to thank. Thank you, Laura May, for joining us.
Thank you.
And thank you to the AAS press office that helped us do this show live from this wonderful meeting we've been able to attend. Next month, we'll report on the headlines from this meeting. We'll be back live at Griffith Observatory. You can come to the show live if you want to see it. And we'll be live streaming it on Griffith Observatory's YouTube channel, of course. And we will have, on next month's show, Dr. Joel Leha, Associate Professor of Astronomy and Astrophysics from Penn State, to talk about those little red dots that JWST has been seeing. So we'll hear his opinion on what those are. At meetings like these, we've been hearing lots of different hypotheses, of course, and we'll see what he has to say. So come on back next month for All Space Considered, everyone. I'm Dr. David Reitzel. All Space Considered is brought to you by the City of Los Angeles Department of Recreation and Parks. And as always, we like to thank Griffith Observatory Foundation, our exclusive nonprofit partner. We'll see you all next month.
Thank you so much.